All right, this is section 4.2. We're talking about models with linear functions. Okay, so how do we use linear models and how we get them from verbal descriptions? So number one, identify changing quantities and then define descriptive variables to represent those quantities. When appropriate, sketch a picture or define a coordinate system. So the things that are changing, we're going to label those as X, Y, Z, something like that. We're going to try to represent those quantities with a variable. Carefully read the problem to identify important information. Look for information that provides values for the variables or values for parts of a functional model, such as slope and initial value. Anything that we are used to working with that we've already learned, we'll try to find something, if we can, that we're used to applying in just a regular situation, not a real world situation. That'll help to simplify it. Carefully read the problem to determine what we are trying to find, identify, solve, or interpret. We have to make sure that we're finding what they're asking us to find so we don't waste time finding something that they didn't even ask us. Identify a solution pathway from the provided information to what we are trying to find. Often this will involve checking and tracking units, building a table, or even finding a formula for the function being used to model the problem. So in our cases, we're going to have formulas that we're going to have to come up with based on the information that they give us and try to solve it from there. When needed, write a formula for the function. Solve or evaluate the function using the formula. Reflect on whether your answer is reasonable for the given situation and whether it makes sense mathematically. For a simple example, if you are trying to, say, double a recipe for something, and you know that the original recipe says, okay, just put a cup of, say, sugar into the recipe. But by the time that you get done changing the recipe and trying to double it, something went wrong and said you came out with, well, now I have to use 3 pounds of sugar for my recipe, when really all I needed was 2 cups. So that's what it means by make sure the answer that you get is reasonable for the situation that is given to you. And then clearly convey your results using appropriate units and answer in full sentences when necessary. Now, when it says convey your results using appropriate units, usually the units that they give you in the problem, those are the units that you'd want to use as well in your answer. And when it says use full sentences when necessary, that just means put everything back into English so everybody can understand what you found in the problem. Okay, Jamie is choosing between 2 truck rental companies. The first, Keep On Truck and Inc., charges an upfront fee of $20, then 59 cents a mile. The second, Move It Your Way, charges an upfront fee of $16, then 63 cents a mile. When will Keep On Trucking Inc. be the better choice for Jamie? Now, before we can even answer that question, when will Keep On Trucking Inc. be a better choice for Jamie, we got to figure out the formulas for Keep On Trucking Inc. and for Move It Your Way. So for Keep On Trucking, I'm just going to label with a K. The cost function for that would be, it says $20 flat fee, $20, then 20 cents for every mile they go. So we're going to let X be the number of miles they drive. So it's going to be $20 flat fee plus 59 cents per mile. And we're going to say that X is miles. And then Move It Your Way charges an upfront fee of $16 plus 63 cents for every mile. So we'll label that X for miles. Then our question is, when will Keep On Trucking be a better choice for Jamie? So a better choice in this situation would be the one that has a lower cost. So what we would do is we're going to take these two, and let me put it over here. I'm going to take these two, set it up like this. Now we said that Keep On Trucking, when it has a lower cost, that's when it's going to be a better choice for Jamie. And both of these functions are cost functions. Okay, so we want this cost to be lower than this cost. That's the question. So we're going to have a less than sign. And then all we have to do is solve for x here. So I'm going to move over the 63. So I'll get 20 minus 0.04 less than 16. Subtract 20 from both sides, so 0.04 less than -4. Should be an x right there. Divided by negative 0.04. Now when I divide by a negative and I have an inequality, that's going to flip. So it's going to be x greater than, and this comes out to be 100. Okay, now remember x was for every mile. So that means if Jamie drives over 100 miles, that's when the Keep on Trucking Inc. is going to cost less than the Move It Your Way company. So that would be your final answer right there. Okay, a streaming service has a daily plan where a customer pays a flat daily fee and then a certain number or amount of money per 1 gig used on a service. If a customer uses 23 gigs, the daily cost would be $19. If the customer uses 85 gigs, that should be daily right there. The daily cost will be $76. So find an equation in the form y equals mx plus b, where x is the daily gigs used and y is the total daily cost of the streaming service. Okay, so we have the x value is gigs, the y value is cost. So our x, y coordinates is now gigs and then cost. So we'll put $signs there. Okay, so then we can turn this sentence right here into an ordered pair. So that would be 23 gigs, $19. And then we'll do the same thing here. This would be, and 85 gigs and $76. Now we're trying to find an equation of a line given 2 points. Okay, so we can label this as x1, y1, this one x2, y2. So we can have slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that would be 76 minus 19 over 85 minus 23. So that would give us 57 over 62. So that would be my slope. So let me put that up here. Okay, then we get rid of this. Now we can use our point slope formula. So y minus y1 equals mx minus x sub 1. So y minus 19 equals 57 over 62. X minus 23. Okay, so then we have y minus 19 is equal to 57 over 63x minus 57 times 23 over, sorry, that should be 62 over 62. All right, so we got y minus 19 equals 57 over 62x minus, 57 times 23, 1,311 over 62. Then we're going to add 19 to both sides. So y is equal to 57 over 62x minus that number, and then plus 19. I'm going to put 19 over 1. Now I need to multiply this 62 over 62 so the denominators are the same. So that will give us y is equal to 57 over 62x minus 1,311 over 62 plus, that's going to give us 1,178 over 62. Okay, and then what we have is basically negative 1,311 plus 1,178 all over 62. That gives us negative 133 over 62. Okay, so there's our equation for the cost of the stream and service plan, where y is the cost, x is the number of gigs that you use daily. In 2017, the school population was 2,164. By 2020, the population had grown to 3,297. How much did the population grow between the year 2017 and 2020? Okay, so we would take 3,297 minus 2,164. So that would give us 1,133. So I'll put that right here. How long did it take the population to grow from 2,164 students to 3,297? Well, this was in the year 2017. This was in the year 2020. So 2020 minus 2017, so that would be 3 years. Okay, this is continuation of the same problem. What is the average population growth per year? Okay, so we've got growth per year, so divided by year. So the amount of growth we saw back here was 1,133 over the years would be 3. So this actually comes out to be 2,575.66, or we'll say 67. Okay, remember, average is the same thing as slope. So basically we found the slope. Because how we got the 1,133, we did 2020. Oh, sorry. We did 3,297 minus 2,164. And we did 2020 minus 2017. So it looks like we have the order pair 3,297 with the 2020 and 2,164 with the year 2017. So it looks like this is x sub 2, y sub 2. This was x sub 1, y sub 1. So really what we found was the slope right there. I'm going to keep it as this for now. So then it asks us, what is the population in 2012? So what we need to do is we need to use or find a formula. So we need to use point slope to get an equation, and then we can plug in 2012 for our x value. So I've got my x sub 1, my y sub 1. So that's y minus 2017 is equal to 1,133 over 3 times x minus 2,164. Okay, so then we have y minus 2017 is equal to this times x minus 1,133 times 2,164 all over 3.